The last few weeks I've had the honour of giving 3 lectures in Melbourne and 1 in Queensland, and I've got about 5 more coming up in the next 6 weeks. First of all, my background. I think it's best to say that. I was a Catholic priest scientist, which you probably find unusual, belonging to a French missionary order, and we were very free to do anything we liked. Some of us were scientists, some of us were linguists, more like the Jesuits. Anyway, after some years, I got appointed as the United States Naval Chaplain to Antarctica. The Americans reckoned that if they had someone who could do 2 jobs, it saved them a bit of money. So I went down there as chaplain to the South Pole itself, to McMurdo Station, where there's 1,000 people in summer, and also as a micropaleontologist for the Americans' first drilling program in Antarctica. Obviously, I'm no longer a Catholic priest. I retired and decided that marriage was a nicer option. Still a Catholic, of course, but and then I had to join the business world for a while, and then I came back to academia in 2005. I won't bore you with all that. In 2011, an American university gave me their Scientist of the Year award, which was the first time ever given to an Australian for my contributions to Antarctic research. So much for that, but I think it's important that you know a little bit about the guy who's actually talking to you, and I'm not trying to hide my past. Today we're in a situation not that much different from the late 1500s. In the late 1500s, science was developing but getting a bit tricky. The Catholic Church was the main religion, but the English had broken away, Germany had broken away, and in Switzerland the Calvinists were getting going. The church was in a very defensive situation. 100 years prior to that, it was very open slather. When Copernicus suggested that the sun was the centre of the solar system, not the earth, the Pope and the cardinals told him to get his ideas out everywhere. They were congratulating him. But now there was a defensive situation. And it was hard to do science. Look at Galileo. And then there was an Italian count or prince, Federico Sisi, and he started the Academy of the Lynxes. Now, a lynx is supposed to be one of the animals that has the best eyesight. So he said a scientist has to just describe what he sees, not what he thought he should see, not what other people said he should see, but what he actually sees. And Galileo was a member. And boy, today we're in the same boat. Are scientists describing what they see, or are they really mixing up what they see with all these other isms? And that is one of our biggest problems.
So who was that guy?
Federico Sisi.
That was him?
Yes. And that is his Accademia delle Scienze, and it didn't last much longer after his death. Galileo, of course, was a member. So when people say what they are seeing, a lot of people today are seeing a very dark future for the Earth. The Anthropocene. Now man is affecting climate. Man is going to turn the world into a parched Earth. We've all heard of Michael Mann and his crazy hockey stick. But why don't we have a look at, start there, because it's easier to start with factual data that ordinary people can understand rather than getting into complicated physics. The idea is that we're going to have more frequent and severe storms. We're going to have catastrophic sea level rise. That is this Anthropocene that a lot of people are actually preaching. We've got our famous Tim Flannery. But every country's got them. America had James Hansen, who predicted that New York would be flooded by 2010. And a lot worse. And he's still going, he's retired. Now he's preaching from his kitchen with his leather hat on. In Germany, we've got Hans Joachim Schellenhuber, funded by Angela Merkel, the Potsdam Climate Impacts Group. 400 scientists working there. The Earth is on 7 tipping points, according to Schellenhuber. One of them is sea level, one of them is methane. It doesn't stop. And in England, you've got Peter Wadhams at Cambridge. At one stage there, he thought that the oil industry had murdered 3 climate scientists. Some climate scientist was cycling to Oxford and was killed. Another one fell down a stairwell. And I forget what happened to the third, but Peter blamed everyone. And he tells everyone that all the ice will be gone in Antarctica next year. He never stops. In New Zealand, we got Peter Barrett. I worked with Peter in Antarctica. I know him well. Peter can't stop. Last year he gave a YouTube telling that New Zealand had to cut the cattle because of all the farting of the cows.
And the sheep.
And the sheep. Bah. That's right. Now, what's happening is every event someone is saying is climate change. And Will Steffen would be the worst, wouldn't he? If you want a go-to person, get poor old Will. But they even get to the stage that a cold snap is called climate change and therefore related to global warming. Now, I want to get onto storms because there's a great book. You may get it in the library. It's worth a lot of money if you got it in your own library. Historic Storms of the North Sea, British Isles and Northwest Europe. Hubert Land started the Climate Research Unit at the University of East Anglia in England. He had a gut feeling that when it was colder, storms were worse. But of course, he didn't have enough data to get a good statistical proof of that. But what about this great drowning? I can't pronounce it in Danish. There was this great drowning in Denmark. 67 villages wiped out. Some islands were just disappeared. 25,000 people dead. The All Saints Storm, 1570, 100,000 people dead in Belgium, France, Holland. But then the Great Storm of 1703, the wind was so great, 700 ships were blown up the Thames. The western end of the Thames was a mess of wood. 10,000 sailors lost at sea. Now, these, you could say, are the 1 in 1,000 year type storms. The only good statistical record we've got of past climate is in China. Some of the semi-official gazettes from coastal towns in China recorded typhoons. The best one goes back 1,000 years of typhoon records. The worst years during the Little Ice Age in the 17th century and in the middle of the 19th century. It's amazing. China never ceases to amaze, I think. But we say, well, wait a minute. We all want to belong to this Academy of the Lynxes. We've all got good climate data now. What does the data say? Well, look. This is all the hurricanes that have hit Florida since 1850 odd. The black line is the rise of CO2 since 1850, 40% rise. Everyone is saying as CO2 goes up, there's more storms. I just challenge you to find that in that data. US tornadoes. Maybe 1974, that was probably a really 1 in 1,000 year event. It was in April and they had 100 tornadoes in 2 days. I've actually found a book by accident in a Canberra library only 2 weeks ago describing, I couldn't believe I actually found it, describing those 2 days. There's Australian cyclones since around 1970, probably going down a bit. But there's no clear evidence that CO2 is doing anything to storms. Now, Professor Farquhar won the Prime Minister's Award for Science a couple of years ago. I've had an hour and a half with him last year. He works on the exchange of carbon dioxide and water vapour at the undersurface of leaves. He's interested in wind and evaporation because the more evaporation, the more a plant loses water, etc., etc., etc. his research has been showing that winds have been dropping in the interior of Australia for 30 years. And he said, well, I'm not a climate scientist, but the models are saying the opposite. But probably the most important slide is this one, because people will say, oh, look, Howard, you're deceiving us. You're giving us frequency. We're talking about severity, and that's very different. Well, the Americans have been keeping in their typical thoroughness. The Americans really are an incredible race. What they've done, what they've funded. The highest winds every 6 hours in the tropics, every 6 hours, have been kept since 1970. Now, if you lived at one of these points here, you might say, oh, things have been getting worse. And you'd be right. Worse for 5 or 6 years. But when you look at the whole trend, there's no trend and there was no correlation with CO2.
What's happened in the last 5 years?
Oh, I don't have that stats, sorry. We're mixing up population trends with frequency and intensity. We're mixing things up. This is just crazy. Florida, 1900, 500,000 people. 1960, 6 million. Today, 23 million. So if there's any sort of storm, there's more damage. We're mixing up damage, population increase, and we're arguing the wrong things. My grandfather bought a house at Southport, because I'm a Queenslander from between Toowoomba and Crow's Nest on the Nanango Kingarow Road. He bought a house for £400 in 1946. I looked it up. There was 45,000 people between Southport and Tweed Heads then. Now you're getting up to well over 500,000. So let's leave storms. Let's look at the data on sea level. Tonight, some people from the Jervis Bay area have come from the Collingwood group. Their problem, of course, is what the councils are saying about what's going to happen to sea level. When the world warms, the water expands a bit, sea level rises, and of course if glaciers melt and all that, you'll get a rise in sea level. What do people see? Well, the bald-headed Hans Joachim Schellenhuber at Potsdam Institute, funded by Angela Merkel, 2 metres by 2100. And he's also advising Pope Francis, I might add, which is a pretty sad situation. If you take the general IPC, they've got various pathways, but an average is around 80 centimetres. And your tide gauges all over the world, 15, 17. Now, traditionally, sea level has been measured by tide gauges. Normally, the ports had them so they could get the ships in and out. They had to work out what depth the ships could go into the water and all that. And some of those gauges are very well kept. If you want to check a tide gauge, go to the internet, type in Fort Denison or whatever, Albany, and they will give you the number for that gauge. Then go to this Liverpool database and you will see a graph of whatever they've kept. That's for the whole world. Now, the sea level's been rising steadily. That's the ramp on the left. Big difference between accelerating, meaning getting steeper and steeper. There's no evidence of acceleration. There is now a NASA satellite system also, apart from tide gauges, and it compares its measurements to a theoretical mathematical shape of the Earth called a geoid. The accuracy per run's only 2 centimetres, but then with continual iterations, they were trying to get something more accurate. That satellite's been a disaster. This system shows sea level rising 3 times more than Fort Denison does. In Germany, it's out 200%. It's all over the place. But the average at the moment it's showing is sea levels rising at 30 centimetres a century. Now, in 2011, I came out on the radio and said that all these projections were dead in the water. Sea level was not running at 30 centimetres a century. based on the work of Professor Houston from the US Army Corps of Engineers and Professor Dean from Florida State. They measured tide gauges all over the world. They said there's something wrong with this ruddy satellite because all the tide gauges are not doing that. There's no acceleration anywhere. And the Australasian data, which they got from the CSIRO, was showing a very slight deceleration for the last 20 years. No evidence of acceleration. The satellite system might have serious design problems. If you go to Liverpool, some of these tide gauges they've got different scales, but there's a few: Wellington, Honolulu, the Battery at New York, Fort Denison, for example. If they were accelerating, they'd be curving right up. Now in 2012, after I got sacked from Macquarie for criticising the CSIRO, which I regard with a badge of honour, I might add, and Media Watch did a show on me, dear old Jonathan Holmes, NASA came out and admitted there were problems with the satellite, saying they really needed to put up a new system called GRASP, Geodetic Reference Antenna in Space, but they haven't been able to get the money from Congress. And when they design a system, they give it to a university on a contract. They don't run it. So Colorado, the university there, is running this satellite, and if you go to its website, it doesn't tell you there's troubles with the satellite system, whereas the head satellite design engineer has been emailing me saying we desperately want the money from Congress to put up a better system. That's the GRASP system. In 2014, two professors from Caltech also came out and said the satellite's a mess. We're calling it jumping frogs, and we shouldn't be using that at all for any of our sea level forecasts. Well, what's the IPC done, the International Panel of Climate Change, done about this? Well, between 1990 and 2001, all of those meetings, all the experts in the IPC agreed there was no evidence of any acceleration of sea level from tide gauges, none whatsoever. Professor Warwick was the chairman of the first one. Even the CSIRO, John Church, was the chairman in 2001. But then in 2007, Professor Bindoff from Tasmania was chairman, and then they decided that we should take the satellite as the best, and we should adjust everything up to the satellite. And that's the situation now with the IPCC. So what you've got the tide gauge straight line, and then suddenly the sea level decides to behave differently and it veers off. The satellite is deceptive, it's wrong, it should not be used. Now with regard to Fort Denison, the crazy thing is that when some environmental engineer is asked to give a report, say to the Shoalhaven Council, Eurobodalla, he's too scared to take the tide gauges. He doesn't want to be called a climate skeptic. So what he does, he says, look, we've got to adjust Fort Denison up to that satellite. And they call it a linear fit. Honestly, I know a little bit about maths and physics. I don't know what they mean by that in this case. So Fort Denison is adjusted from 8 centimetres a century to 30. And that's what a lot of the councils are doing. It's madness. If we belong to this Academy of the Lynxes, we've got to be humble enough to describe what we see and what is real and then adjust to that. So if you belong to a coastal council, I really pity you, because how are you going to handle the rest of the council? It's not a place for debating climate change. It's a place of deciding what is the best data for our sea level projections to the future. And I tell the councils, look, I'm not here to get you involved in the whole of the climate debate at all. It's a matter of listening, say, to Professor King, the chief scientist in New South Wales, who says you can use the tide gauge data if you want to. It's a matter of you choosing what you think is the best data. And it's very hard to prove that the satellite data is the best. The people here from Jervis Bay would know this, but when I researched beach behaviour in this area, what I did was, I'm a field geologist and a micropaleontologist. I took aerial photographs from 1948, 1970, and I compared them using a CAD system with a computer. When you overlay them, shock horror, the vegetation's gone mad. The vegetation has been trapping sand, and this is 1948, and this beach has been growing seaweed because the fore-dune vegetation and the dune vegetation has exploded so much that has been trapping sand. So when you have low water, sea level rise, this can happen. This is another beach down there, the Warrain Beach. Look at the difference. On the left, you can see this, all the sand, now vegetation. And if you take a beach well away from human beings, Kinghorn Point between Culburra and Jervis Bay, here's your fore-dune, and you can see here the vegetation is trapping so much sand it's going right up to the high water mark. So that beach is advancing seaward. The people here from Collingwood Beach will tell you that that beach has grown about 8 metres since 1850. Kalala has done nothing, it's been stable. Some of these beaches on the sea have grown a little bit. So you can't have a uniform coastal policy in New South Wales. The beach isn't going to behave like this, say, up at Bar Harbour or Port Macquarie. You've got to do this type of comparative photogrammetry everywhere for each region and then come up with a proper policy. Now, where did all these predictions come from? The predictions of rising sea level, storms. Well, welcome to model land. They came from computer models. Now, the first computer model was a guy called Manabe. He came from Japan to Princeton, quite a genius, and their computer had 0.5 megabyte of RAM. Isn't that amazing? They created a world which was only 120 degrees of latitude. Half was land, half was water. And then, of course, you've got to have a few layers, and then you've got to divide the world up into cells. So their cells were huge. And Kirk Bryan, who was working on the oceans, went with him, and they thought that with their model, if you doubled CO2, the world temperature would rise 2 degrees. Now, if you go to IPC documents, you'll see there quite often they say models are imperfect. Models should never be used as predictive tools. But what's happening is everywhere they are being used as predictive tools. There are unknowns not in the models. And there's also nonlinear chaotic behaviour that a model cannot replicate. In climate research and modelling, we're dealing with a coupled chaotic system, and therefore the prediction of future climate states is not possible. IPCC. You won't find that in the summary statement that's made to the whole world after an IPC meeting. You'll have to go to the long technical reports that no one ever reads to find that type of statement. Now, one of the key things in this talk tonight is where science went off the track. It was 1979, and the National Academy of Science in the United States had a meeting trying to work out, could they come up with a sensitivity index as to what would happen if CO2 levels doubled. It's called an Equilibrium Climate Sensitivity Index. The meeting went for a week. I think Garth Paltridge, who was the chief atmospheric scientist at CSIRO, was there. Now, when they did that, they had only about 2 computer models to look at. One was Manabe, and Hansen, who's a great catastrophist, he'd been working on Venus, and his model said 4 degrees. So after a week, they came up with this sensitivity index between 2 and 4. But the key things in this index are carbon dioxide, only 1 degree, water vapour 0.7, cloud cover 1.3. That gives you the average of 3 degrees. What it means is that water vapour and clouds triple the effect of CO2. So what a lot of you probably don't realise, this modern climate debate is really not about carbon dioxide. It's about the fact that in the computer models, water vapour and clouds triple the effect of CO2. So if the physics of water vapour is wrong, or the physics of clouds is wrong, the whole of the edifice built up by the IPCC, since when it started around 1990, falls over. Now albedo, by the way, is the reflectivity of the Earth. So some of the sun's radiation never gets to the surface. Some is reflected by cloud, some by hitting molecules in the atmosphere, and then some, of course, at the surface. So let's start with albedo. The albedo of the surface is probably only about 17%. Clouds and hitting molecules in the air a lot more. But with regard to albedo, you've probably heard a lot, oh, there's less snow cover now, so the Earth's absorbing more heat. Well, if you look at the Arctic pack ice, you can see that it's been decreasing since 1980. But while it's been doing that, the Antarctic pack ice has been increasing at a greater rate. And no one can explain that. So the albedo, or the lower albedo in the Arctic pack ice, is being more than offset in the Antarctic. What about clouds? Well, if you go to the IPCC documents, they'll tell you that half the scientists think clouds have got a negative effect in the models and half positive. And the IPCC will tell you time and time again the biggest problem in the climate models is clouds. So how can we dance around using clouds? Half the models have opposite views on the role of clouds. Clouds are the largest source of uncertainty in climate science. So that's just a reminder of that thing. So what about water vapour? Well, water vapour is about 90% of the greenhouse effect. And that was proved years ago by an Irish physicist we'll get onto in a moment. And if it's 90% of the greenhouse effect tinkering with CO2, we're only tinkering with something that's far less than 10%. If we look at this diagram, on the left you've got the shortwave radiation at the top coming in from the sun, and on the right up here you've got the long-wave radiation going back up. Here's water vapour. Water vapour is absorbing at all these frequencies. Carbon dioxide is only absorbing at a few. So here, at this critical point, 10 to 15 micron, carbon dioxide is competing with water vapour. In the tropics, it wouldn't matter if there was no CO2. It's totally dominated by water vapour. If you look at methane, that's supposed to cause a catastrophe, methane only absorbs at a few little bits. It's like going to a meal with someone that's only got a picky diet. It can only have a couple of things. Methane can't do a lot. Once it's eaten as much as it can't do any more. All of this was proved in 1859. John Tyndall was an Irishman, went to teach in Wales, was bored. Another teacher and he decided to go to Germany and do science. He came back, became a famous scientist at a London institute, sponsored by Prince Albert, Queen Victoria's husband. And in June 1859, he gave a speech about an experiment he'd been doing for months to see which gases in the atmosphere could absorb long-wave radiation. The French had suggested it, no one had been able to prove it. And what he showed was that oxygen and nitrogen, they didn't do anything, but water vapour is the main, what we call now the greenhouse gas, and that methane, ozone and carbon dioxide are very, very minor in the whole story. I could give a lecture on this, and I won't. This is his apparatus, but this is the brass tube he had where he put the gases. He realised he couldn't put glass ends because that'd be trapping everything in. So he found that if he had thin slivers of rock salt from Germany, from a German salt mine, and they let radiation through easily, that would solve that problem. And then he had a boiling water source, so he had a constant heat source on this side. I won't go into the rest, but he explained this experiment and all the problems in about 60 pages, detailed pages. But eventually he showed that water vapour was the king. And at that time, and for the next 50 years, the scientific debate wasn't about greenhouse gases. The scientific debate was, we now know there's been ice ages, at least 4 in Europe. What the hell causes an ice age? So the early climate debate in the 19th century was not like the one we're having to do today. It was, how the hell did we have ice ages? So I've showed you that. So if we take a satellite instrument looking downwards, you can see here that there's the gap where water vapour and CO2 have taken stuff out that's being absorbed. This is the ozone gap. The gap here doesn't tell you what's doing what, but it clearly shows that they are absorbing some of the long-wave radiation that would otherwise have gone back into space. Now, in these computer models, they did predict that as the world got warmer, there'd be more water vapour in the tropics. And in the early models, they all predicted a big tropical hotspot between 5 and 12 kilometres in the atmosphere at the tropics. It was in all the early IPC reports. The trouble is, that's what the models predicted. That's all the radiosonde balloons that have gone up measuring the atmosphere in the tropics have never found it. And what a lot of scientists have been saying, if that hotspot's not there, the whole of the climate science espoused by the IPC falls over just in one go. For some scientists, this fact alone is enough to totally discredit the modern climate computer models. Now, what about CO2 calculations? CO2 has been going up since 1850, only properly measured from the 1950s, I might add. So this is an estimate, and then from here on, we've got estimates in Hawaii, Antarctica, from ships and other places. The trouble is that if you try to say that climate's controlled by this CO2, as a geologist, I can tell you there's been ice ages when CO2 has been 10 times today. So if CO2 is that critical, how the hell can you have an ice age when it's up to 4,000 or more parts per million? Was in the Ordovician, was in the Jurassic. It's crazy. CO2 is not that critical at all. And then if you look at history problems, because I'm an historical geologist, I'm trying to come to this from a point of view of historical geology more than physics. Putting out physics is a good way to get people lost. But there weren't a lot of climate data points in the 1700s, but the warming definitely started there. CO2 started to go up around 1850, but between 1850 and 1900 it only went up 10 parts per million. The warming started before CO2 went up. And then as it's gone on, if you look at Glacial Retreat, Glacial Retreat has been pretty much the same. It started before CO2 started to go up, and it's kept on retreating. There's not a marked acceleration in Glacial Retreat at all. And then there's a stepwise pattern. Look at here, the gradient. Here, when CO2 went up a little bit, that warming gradient is the same when it's going up a lot. And here we've got a period where temperatures went down, and the CIA were warning the American president of a coming ice age. The correlation with CO2 is very poor indeed. In more detail, I'm sorry at the back if you can't see this, but we might have warming when CO2 went up at 2 parts per million. Here we've got cooling with CO2 going up at 7 parts per million. Here we've got warming 15 parts per million. Now it's going sideways at 20. The correlation is very poor. So we can say, well, since 1979 in the Manabe model, have models got better? Boy, computers are a little bit different from that 500 megabyte of RAM. Now we've got the British model, for example, hundreds of thousands of cells. Although still, at the tropics, a cell size is 28,000 cubic kilometres. So in 28,000 cubic kilometres, you'll have one value for clouds at a certain place, you'll have one lapse rate for temperature, and you're still dealing with 28,000 square kilometres. A lot of things can happen in 28,000 square kilometres.
Square or cubic?
Cubic, I mean, sorry. And also, if you look at the models, here's your CO2 going up and your temperature's going up. The only correlation is here. And one of the troubles is that computer models were really developed between 1975 and 2000 when CO2 and temperature seemed to be going up in tandem, in step together. But if they'd looked a bit wider, they would have seen that's not the case. I think I've shown that stepwise thing already. So what have the models got right? Accelerating temperature? No, the temperature gradients at various times have been similar, and other times when CO2's gone up, nothing's happened. We haven't had more frequent storms. We haven't had acceleration of sea level. There's no water vapour tropical hotspot. And now what's happening with albedo is anyone's guess. Model land has crashed. This is a famous graph. Here are 90 climate models. Everyone's got them now. China has got about 3 or 4. Australia's got 1. Various universities have their own. If you want to start a model, you can't start from scratch. You need to buy bits from here and bits from here. It's like a model car, and then put it together. And then you don't know what you bought from someone else, because the cost of doing it from scratch, you're talking millions of dollars. So here we've got the average of 90 models. They look okay to about here. This is the Hadkrut 4 is the British surface temperature graph for the world. The UAH is the University of Alabama, Huntsville, that are running the NASA satellite system. Or it's over many satellites that got instruments on them, not one. They're in a good agreement. So temperatures are now doing that. The models are going up there. The models are on steroids. So if we theorise about water vapour and clouds, tripling the effect of water, as soon as we do that, the models, right from that 1979 decision by the US Academy of Science, those models have been on steroids. To finish up my talk, this is a very wise diagram. This Japanese scientist was a professor at the University of Alaska, one of the world's experts on the Van Allen radiation belts around the Earth. He said what he sees, as a member of the Academy of the Lynxes, for example, is an oscillating temperature. And what's happened is that here, the models have just taken off that way. And really, we're in a warming curve, but going up in sort of waves. And I'd like to, near the end of my talk, finish here, because James Lovelock was one of the famous environmentalists of the 20th century. He's now in his 90s. He wrote the Gaia hypothesis. The world was one big organism, and he thought we were all going to fry this century. Temperatures going up 5 to 8 degrees. And when I wrote my book, I had this lovely email from one of the people who bought it saying, Dr. Brady, go and read the Gaia hypothesis because you're wrong. Once you read that, you'll change your mind. I had great fun sending him an email to say, I'm sorry, sir, if you read Lovelock's latest book, he's changed his mind. And it's in my book, in the first chapter, he said, I was wrong. climate's doing its normal things. It's not doing much at all at the moment. And with regard to the warming, he said, for God's sake, let's enjoy it while we can. So here we've got water vapour killing CO2. Is climate change really about carbon dioxide? Or is it really about water vapour and all this index that's being used in the models? Have a lot of scientists had their head in the sand and without the guts to change their mind about what's really happening. And finally, the Flannerys, the Hansons, the Schellenhubers, the Wadhams, whatever, have installed so much panic. We've been told every time we're told we've got 10 years to doomsday. And what's happening is we're then installing infinite alternative energy technology that has to be subsidised. Now, we need to develop very good alternative energy technology. We can't use coal, oil and gas at the rates we're using forever and ever. But why spend all this money subsidising it? Why, at the moment, $1.5 billion a year is going to overseas investors in our wind farms? Spain was nearly bankrupted because they went too fast, too early. What would happen if that $1.5 billion went into our universities and technical institutions to do more research on alternative energy, which we have to develop? There's no denying that. But these guys have created panic. And in the panic, they could start bankrupting our very economy. And so I'm saying that the climate debate at the moment and the whole climate system, it's like 1,000 cats in a room with 1,000 balls of wool. So many different people are getting involved and trying to get people to demonstrate for this, that or anything that really aren't interested in climate, but interested in their own particular agenda. We have to belong to the Academy of the Lynxes. We have to have the guts to change our mind when we look at the data. And as I say in my book, and that's why we use this title, climate science for the last 40 years has been stranded as in an English maze. And it's like in the old days when we used to go to the circus in a little town of Toowoomba where I come from, or near. You would have a tent with all these funny mirrors and you go in and see all these different shapes. Well, what's happened is that the scientists have distorted so much, a lot of us are lost, and unfortunately I'm not too sure when it's going to be sorted out. Thank you very much.